Saha, and now I am going to tell something about NetworkX tool. So, NetworkX is a Python package. It is used for creation, manipulation, and study of structure of complex network. It has data structure for representing various network like directed graph, undirected graph, multi-graph, multi-directed graph, and many more. It's also have some standard graph algorithm for calculation, for shortest path finding algorithm, then cycle finding algorithm, coloring problem solving algorithm, many more algorithms content, more than thousands of algorithm it has. So it contains a variety of functions to calculate density, degree distribution, number of connected components, and many more of a graph. Okay, so the graph internal data structure are based on adjacency list representation and implemented using Python dictionary data structure. Okay, so coming to the installation part, your first of all you need to install Python latest version of Python in your system. Okay, after installing latest version of Python, you just need to run this command pip3 install networkx, and this will install the networkx tool into your system. Okay, you also need some optional packages like numpy, scipy, pandas, and matplotlib for additional functionality. Okay, so coming to the tutorial part, you can import networkx module as import networkx command, and import networkx code, and for abbreviation use nx as nx, because it is very difficult to write networkx everywhere. Okay, we all know how this is work. Okay, so some basic graph data structure are, this graph, it will simply create an empty graph, empty undirected graph. Okay, basically, and this diagraph will create an empty directed graph and store it in the g, that is a object. Okay, so multi graph, it will create a multi data structure for multi graph, and multi digraph, it will create the data structure for empty multi directed graph. Okay, and these all graphs are empty. Okay, so networkx provide several functions to read, write, and grow the graph. Okay, now coming to the nodes. So nodes can be any hashable object. Okay, so any hashable means you the object which has its hash value, the for the object we can calculate the hash value, that can be a node. Okay, so how to add a node? So basically we can add a node using add node function. Okay, add node 1, it will basically add a node 1 to the graph G. Okay, so I'll show you the hands-on tutorial also parallel to this. So because basically it will import a networkx module, and this command will used for importing the matplotlib. Okay, I just run it. It will importing, and here basically nx dot graph name equal to my graph. My graph, it is a parameter, you can give the name of the graph as a my graph. Okay, so graph, it will create undirected graph, empty undirected graph, and it will store in the object g1, and nx.info g, it will print the information about the graph G. Okay, so you can see the information about the graph G. The name of the graph is my graph, type of the graph is simple graph or directed graph, number of nodes of the graph is 0, and number of edges are graph. As I said, this will create a data structure for empty graph. Okay, so number of nodes and number of edges are 0, and here I say add node will add a node 1. Okay, so here I add two nodes. Here add node 2, and g1 dot add node 5 will add a node 5. Okay, and for drawing purpose we used nx dot draw. It will draw the graph whichever the graph we have provided here, g1 graph, and with level equal to 1 means it will also provide the level for the graph. Okay, level for the nodes. Okay, and mpl dot show will show the will plot the graph. Okay, which will draw by the nx module. So you can run. Yeah, you can see the two nodes are created. This is the node 2 and this is the node 5, and these two nodes are created. Okay, so So add a list of node at a time. So we can add a list of nodes at a time using this command, add nodes from Kolkata Raipur. This function will basically create two nodes, Kolkata and Raipur, and add to the graph G. So you can see here I create a list. Okay, list, the value of the list is 0, 1, 3, 4 and 6, and here I write the command, or write the function that add nodes from, and I pass list as argument, and this will basically create the nodes for these values, the values of the list element. Okay, so you can see, and this is for the drawing purpose, and you can see here, yeah. So the nodes for 0, 1, 3, 4 and 6 are created. This is the node 0, this is node 1, this is node 3, and this is node 4, and this is node 6, and we already include node 2 and node 5, so all nodes are here. Okay, so we can remove any nodes from the graph using remove node comma or remove node function. Okay, so here I create a remove node 6 from G1 graph. So G1, this is my G1 graph, and it will basically remove the node 6 from this graph. Okay, so you can see, yeah, they see the node 6 gets removed. Here there is a node 6 here, and here there is no node 6 is not there, you can see. Okay, so yeah, coming to the edges can take any arbitrary data. We can give any arbitrary value to the edges. Okay, so add one edge at a time. Similar, it is also similar to node also. So the add edges will add edge between node 1 and node 2. Okay, so you can come to the, here I write a function add edge from 1 to 2 of G1 graph. So it will basically add an edge between node 1 and node 2 in these two nodes. Okay, so you can see, yeah, node 1 and node 2, they are connected through an edge. Okay, and rest are the disconnected. And we can also give the weight also for the edge using using simply write the weight equal to weight associated with the edge. Okay, so I'll show you this in the later part, in the practical, in the hands-on practical part. So add list of edges at a time. Similar to the nodes, we can also add list of edges using add edges from providing the list. Okay, so here I also write the list equal to, this is the edge of list of edges, and I write the function add edges from, I pass list as a argument. Okay, and this will basically draw the all the edges. Okay, so here I write the edges from 0 to 2, node 0 to 2 there is an edge, 1 to 4 there is an edge, 1 to 4 there is an edge, 1 to 5 there is an edge, 1 to 5 there is an edge, 5 to 3 there is an edge, 5 to 3 5 to 3 there is an edge, 6 to 1 there is an edge, 6 to 1 there is an edge, and 6 to 5 there is an edge, 0 to 4, 0 to 4 there is an edge, and 3 to 6 there is an edge. Okay, and there is already an edge between 1 and 2. Okay, so similar to nodes, we can also remove any edges. So here I write the using remove edges function. So here I write remove edge 5 6, it will remove the edge between 5 and 6. Okay, basically it will remove this edge. So run it. Yeah, you can see the edge between 5 and 6 gets removed, there is no edge now. Okay, so yeah, so some basic property. So coming to the some basic property, the info function will print the information about the graph. Okay, so as I said earlier, so you can see the print nx.info of G1, it will print the information about graph. So name of the graph is my graph, as I said earlier, and here I used, you can see here I used nx.info function, so it will print. And where, yeah, so the name of the graph is my graph, type of the graph is simply undirected graph or graph, number of nodes is 7, number of edges is 8, and the average degree is 2.0 2857. Okay, so you can calculate this average degree, and number of nodes is 7. You can see 1 2 3 4 5 6 7 nodes, and number of edges are 8. 1 2 3 4 5 6 7 8. Okay, there are 8 edges. So yeah, information. Yeah. So we can also print the list of nodes using nodes function, and list of edges using edges function. Okay, so you can see here, print g1 dot nodes, it will print the list of nodes, and number of nodes, we can also get the number of nodes using number of nodes command. So you can see it will, the first print will print 7, which is the number of nodes, and the this will print the list of nodes. Okay, you can see. And for same as the edges also, you can see the number of edges will print the number of edges, and edges will print the list of edges. Okay, so yeah, we can print the neighbor of a particular node also using using a neighbor function. Okay, so you can see here, I write neighbor of 1 of g1 graph. Okay, so g1 graph of neighbor 1, so you can see the graph, it is a g1 graph, and the number of node 1 is 4 uh, 2 4 5 6. Okay, so you can see the printed value is 2456. Okay, so we can get the degree of a particular node also. Here I print a degree of node 1 is printed 5 4. You can see, check here, that this is the node 1, the degree of node 1 is 1 2 3 and 4. Okay, so you can also get the degree also. Now file accessing. So read edges from a, no, it's not a graph, it will be file. Okay, so it's my mistake, it will be file. Read the edge list from a file. So we can read the edge list from a file using read edge list function by providing here file name, and create using the data structure of the graph, and this is the node type, node type. Okay, so you can see here in my directory structure, I created a I created a, oh, sorry, 1 minute, 1 minute, 8 minute. Yeah, home python. Yeah, this is the my file. Okay, file, just yeah, this is my file1.txt. Okay, you can see the data here. Yeah, oh, yeah, these are the data. Okay, so column 1 represents the node set, and column 2 also a node set, and every row represent there is an edge. This 2 1, it will represent there is an edge between 2 to 1. 2 0 represent there is an edge between 2 to 0, and there is so on. Okay, so you can see it will create a graph and store in the temp variable. Okay, you can see this is the graph created by the file dataset file.txt file. Okay, so this is the graph, and similar to this we can also write edge list for a graph also. Okay, so you can see here using this command write edge list, the graph name, this is the graph name g1, and the file name which we want to create, the file.txt. Okay, so you can see in my directory there is no file.txt in my directory. Okay, just make it bigger. You can see there is no file.txt part. Okay, so I just run this function, and now see file.txt is get created, and the data, I'll show you the data also, and this is the data sets, okay, of the g1 graph. Okay, so yeah, file part is over. Now some classical graph operation. Okay, so we can union the two graph we can find the union of two graph, intersection, Cartesian product of two graph, and we can find the complement of a graph, and we can convert a, directed graph into uh, sorry, a directed graph into an undirected graph. Okay, so here for you, so using union of g1 g2, it will return union of two graph, and here g1 and g2 must be disjoint. Okay, so there are no common nodes between g1 and g2. So you can see here, I write the function here, this is a g3 graph and this is a g4 graph, and the union is stored in a g graph. Okay, and we plot one by one. Okay, so this is a g3 graph. I provide the data set here, you can check. And this is a g4 graph, the data sets g4 graph is this, and the union of this g4 and g is stored in g, and this is the g graph. Okay, and similarly we can find the intersection. This is g3 graph for intersection, and this is g4 graph, and the intersection, one important point in intersection, the nodes must be same. Okay, the for the true graph, nodes must be same. So the intersection of g1 g3 g4 will find the intersection between these two graph, and here I similarly I plot both the graph and after the result. So this is g4 and this is sorry, this is g3 graph and this is g4 graph, and the intersection of g3 and g4 is this. Okay, so you can see g4 there is an edge between 1 to 2, 2 to 3, and 3 to 1. Okay, and in g4 there is an edge between 1 to 2 and 2 to 3. So the intersection of these two graph will 1 to 2 and 2 to 3. You can see there the graph is generated is there is an edge between 1 to 2 and then 2 to 3. Okay, so we can find the Cartesian products also using Cartesian product of G passing the two graph G3 and G4. So these two graph, basically these two graph. Okay, so you can see the Cartesian product of this two graph. Okay, this and this. So we can also find the complement of also. So here I for complement here I use g1 graph. So this is the basically g1 graph, and the complement of using this g1 combo nx dot complement function, you can draw the complement of g1 graph. Okay, so you can see this is the graph g1, and the complement of graph g1 is this. You can see uh, in the g1 graph there is an edge between 3 to 6, and in the complement of g1 graph there is an edge, there is no edge between 3 to 6. This is the node 3 and this is the 6, and there is no edge. You can check for the all edges. Okay, so we can also convert a graph into directed graph using two directed function. Okay, you can see here I pass g1 complement, means this graph as an argument to this function. Okay, so you can see there is no direction in these edges, and you can see here it just convert the undirected graph into a directed graph by putting the direction also. Okay, similarly we can also convert this directed graph to undirected graph using two undirected function. Okay, and passing directed graph as here I store, you can see here I store the directed graph in the uh, dg object, and here I pass dg as a argument. Okay, and it will simply convert the directed graph into undirected graph, you can see. Okay, yeah, this, yeah, some classical graph. So we all know what is complete graph, what is complete bipartite graph, barbell graph, and barbell graph. Huh. Okay, so basically complete graph, to create a complete graph we just have to call the complete graph function with provide with the number of nodes. So here I give one example, nx dot complete graph 5, it will generate a complete graph of 5 nodes. Okay, you can see the 1 2 3 4 5, there is a 5 nodes, and this is a complete graph of 5 nodes. Similarly, complete bipartite graph of 3 comma 4, it will create a complete bipartite graph where this is the 3 nodes and this is the 5 nodes, and these are the connected. And we can also calculate the barbell graph. This is the barbell graph where 3 copies of complete graph K4, there is a 3 copies of complete graph K4. You can check, this is a definition of barbell graph. Peterson, you can also create the Peterson graph having Peterson graph having 10 nodes and 15 edges. In this Peterson graph there is a 10 nodes and 15 edges. Okay, and check. We can also tetrahedral graph. This is a tetrahedral graph. So here, as I said earlier, I will show you the weight part here. So here I create a graph G2, and I also provide the weight of the graph. Okay, so yeah, so basically this will create a weighted graph. You can see the weighted graph. This is the weighted. Oops, actually the edges are not properly distributed, so I just change the layout. Circular, so random. Let's see what happen. Oh, as I said, the NetworkX is not good at drawing, so it is not able to put the edges in a proper place. Okay, let's see what happened. Let's leave here. There. Okay, so this is a basically weighted graph. You can check the weight also. Okay, so some algorithm packages. NetworkX provide various graph algorithm like shortest path, breadth-first search, and clustering and isomorphism algorithm, and others. So here I list down some graph algorithm packages. These all are packages. Okay, so NetworkX also include packages for traversal type of algorithm. There are many algorithm regarding traversal. You can go into this link and you can check. There are more than, I can see more than hundreds of algorithm are there. Okay, for all these packages. So for shortest path also there is a package, for centrality there is a package, for chains there is a package, for click measuration there is a package. uh, every component, every algorithm there is a package. For clustering there is a package, for coloring there is a package, and this packages include lots of algorithm. Okay, you can just go to this link and can check. Here I only discuss about some one algorithm, that is shortest path finding algorithm. Okay, so the shortest path algorithm we can call as like nx dot shortest path of G2 from node A to D. You can see actually it is not showing properly, so here I am only show you. So shortest path between node A to D is there is a two path. You can see from here there is a two path, one A to B and B to D, and there is another path A to C and C to D. So A to B there is a weight, A to B there is a weight 4, and B to D there is a weight, B to D there is a weight 2. 4 plus 2 is 6. Okay, the weight is 6 from here to here, and the A to C and C to D there is a path, and A to C and C to D. The A to C, the weight is, A to C there is weight is 4, and C to D, C to D there is a weight is 3. 3 plus 4 is 7. Okay, so shortest path is this A, B, D, and you can see the output of this shortest path is A, B, and D. Okay, so this is now using NetworkX we can measure different type of node centrality. Okay, for calculation of node centrality we can use uh, calculation. Yeah, we can using NetworkX we can measure different type of node centrality. For example, like we also calculate the degree centrality of a graph, closeness centrality, betweenness centrality of a graph. Okay, so basically degree centrality will return a dictionary of node with their degree centrality value as value. Closeness centrality will return a dictionary of nodes with closeness centrality as their value, and betweenness centrality will return dictionary of nodes with betweenness centrality as their value. So for more details on centrality, you can I provide this link actually you can find lots of centrality algorithms are there, so you can go to this link and check once. So here I give some hands-on practical for, let's suppose I calculate the degree centrality of G1 graph. So degree centrality of G1 graph here, as I saw, see, this is our G1 graph. Where is it? Where? Let me show you. G1. Let me print first. Let me draw for you here the G1 graph. Okay, just copy it. Just show you the G1 graph. V G1 G1. Okay, so yeah, this is our G1 graph, and the nodes are the degree centrality of node 2 is this, and then of node 5 is this, and you can see it will print a dictionary of nodes with their value. Okay, so same, we can calculate the eigenvector centrality. This will also provide degree dictionary of nodes with eigenvector centrality as their values. For closeness centrality we can also calculate same using closeness centrality of G1, and for betweenness centrality we can also calculate like this. Okay, so you can calculate and you can check this link for more. So drawing of a graph, as I said earlier, the drawing NetworkX is capable of basic graph drawing with the help of matplotlib library. So as you saw in my tutorial part, the drawing part is not as good as other tools, networking tools are have, like Gephi gave you the good networking environment, uh, good good visualization. Okay, so various type of drawing function are available under NetworkX drawing module. Okay, so, here I give you some basic drawing functions. So draw function will draw the graph with the help of matplotlib. Okay, draw G will draw the graph G. With labels means it will print the labels also, and we can change the font also, like bold or whatever you want you can put here. Okay, so now draw network X nodes. It will draw the nodes of the graph G. Okay, and we can also draw the edges of a graph using draw network X edges function. So draw network X, actually this thing is error part, and you can see the function is from here. So draw network X level will print the level or level of the graph, and draw network edges edge levels will draw the edge level on the graph G. Okay, so this will label the edges, and this function will label the nodes, and this will label the edges. Okay, and we can also give the layout for the graph drawing, like using draw circular. It will This function will draw the graph in a circular layout. Okay, so same as the circular, we can also network X also have many layout like planar, random, spectral, spring, and many more things. There are many more things in the layout. You can just, for more information, you can just click here. I could provide the link for the graph layout, graph drawing. Okay, so you can check here. So coming to the limitation part, network X is just slower because of it is built in a Python, pure Python, so it is bit slower. Okay, so it is not recommended for large networks having million number of nodes. So as it is slower, if there is a nodes are millions or billion edges, millions number of nodes, then it is take too much time for calculating those things. Okay, so it don't have better use of memory or threads. It is just simple tool and doesn't have memory utilization capability. and visualization of network is better handled by other professional tool. As we see in our tutorial that the visualization of network is not better in NetworkX. Okay, so you can use other professional tool like FE or something else you can use. Okay, so hands-on tutorial. Coming to the hands-on tutorial, here I give you a tutorial on a virtual node network. It is not a real node network. Here just I take some random data and just try to give you some example. Okay, so city set, it is a list and it will contain a city of say of cities of contain name of 9 cities like Kolkata, Patna, Bhubaneswar, Raipur, Delhi, Mumbai, Pune, Surat, Malda. And G1 dot network X, it will create an undirected graph data structure for undirected graph and add nodes from city set. It will create the nodes for the city sets for Kolkata, Patna, Bhubaneswar. Okay, and this will print the these things for the printing part, drawing part, sorry. So this will here we can see the nodes for every city. Okay, and these nodes will represent every city. So we also have the path from from between two city path between two cities. Okay, for this reason, and here as I create a virtual network, so here I don't take the exact value, here just I create random value. So for this I use a cost list. Okay, so this cost list content a number of cost like 100 to 2000 values, and this will this will represent the cost between two cities. In the later part I will say how. So here I add, no, I add 6 edge. Here I add 6 edges to the network. Okay, and randomly I add randomly 6 edges to the network, to this graph. Okay, 6 edge only. So while g dot number of edges is less than 6, then if this condition is for true, then if the number of edges is we all know the number of edges will return the number of edges of the graph g, and it will run the loop till the number of edges of graph g is equal to 6. Okay, so here I, for randomly choosing purpose, here I use the random package. It will choose the random value from city sets. Okay, so for c1 equal to random dot choice of city sets, it will choose random. It will take any value from the city sets, city set list. It will give city set list, and c2 for same as c2, it will also take any city sets from the city set list. So here we have two city sets, city, and if c1 not equal to c2 and c2 dot has edge between c1 and c2 equal to 0, if there is no edge between c and c2, then we can take some random cost value from the cost list. This is the cost list, any random value we can take, and we add edge between c1 and c2, and the edge width of this c1 c2 is w. Okay, means the distance between these two cities is w. Okay, so this will basically draw a random graph. You can see, oh shit, it is not showing well, actually it is jumbled. So here I use circular layout. You can change as a spectral, I can use as a planar, PLA or planar PLA, sorry, planar till not draw. Okay, circular is not working. C random random. Okay, random, it is m. So actually it is not getting printed. Let cooler. Okay. 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 See here, circular. So actually it is not showing, so let's leave this part. And each connected function will print true if the graph is connected. So you can see, as I add only 6 edges, so it is not a connected graph, so it must return false. Yeah, this return false because it is not a connected graph. Okay, so yeah, so now we print the uh, if there is a path between two nodes or not. Okay, so for this purpose we use to loop for u in g1 dot nodes and for v in g dot nodes. Okay, this will select two nodes and print from u to v path or not nx dot hash path will return true if there is a path between two nodes. Okay, so I run this and you can see the output. From Kolkata to Kolkata there is a one node and there is always a path, so it is true. And Kolkata to Patna there is no path, so it's written false. Patna, Kolkata. Okay, you can see here from Patna to Delhi there is no edge, so you can see there is Patna to Delhi, Patna to yeah, Patna to Delhi path has or not is false, so there is no path from Patna to Delhi. Okay, so similarly you can see here from Bhubaneswar to Kolkata there is a path, it's written true, and this written true and sometime it's written false. Okay, so this will return true if there is a path between two particular nodes. Okay, now I want to find the disgustor path length. Okay, from one node to another node. Okay, so for this region I here write this function and printed the disgustor path length. Path from Etoy and path does not, if there is no path then it will throw an exception, and for this in this region here I use try block and try an exception block. Okay, so this will, you can see the output. Okay, so path from Kolkata to Kolkata, discuss the path there is always exist and the path length is 0. Okay, and path from Kolkata to Patna, path does not exist. Okay, actually Kolkata to Patna there is no path. You can see here Kolkata to Patna, Kolkata, yeah, Kolkata to yeah, here you can see from there is no path, false. Kolkata to Patna there is no path. Okay, false. So there is no path from between Kolkata to Patna. And you can see here path from Kolkata to Bhubaneswar. Yeah, there is a path from Kolkata to Bhubaneswar, and the disgustor path is Kolkata, from Kolkata to Mumbai, Mumbai to Pune, Pune to Bhubaneswar, and the path length is also 2400. Okay, the length of the path is this, and similarly we can find all the things. And yeah, this is the things, and that's it from me. Thank you and have a nice day. Thank you.